A company offers a basic life insurance to its employees as well as supplemental life insurance. To purchase a supplemental policy, an employee must first purchase the basic. Let X denote the proportion of employees who purchase basic and Y the proportion who purchase supplemental. Let X and Y have joint density function 2 times X plus Y on the region where the density is positive. Given that 10% of the employees buy basic, calculate the probability that fewer than 0.05 buy the supplemental. So over here, we first find the region. They say that we are interested in the region where the density is positive. So at first sight, it may seem that, okay, since X and Y are the proportions of employees, so we're just dealing with X between 0 and 1 and Y between 0 and 1, but no. Yes, X would be between 0 and 1 because X doesn't have any additional restrictions besides the fact that it's a proportion who buy the basic. So X is between 0 and 1. Okay. But Y has an added restriction on it because Y is the proportion who buy the supplemental. And to have the supplemental, you also have to have the basic. So the proportion who have supplemental cannot be bigger than those who have basic. So it means Y has to be less than or equal to X. Y is the supplemental, X is the basic. More people can have basic, but supplemental cannot exceed basic. And Y is bigger than or equal to 0. So note that here I had X strictly greater than 0. Not that it makes any difference in calculations, but just from a mathematical point of view, since we want the density to be positive, so if X were to be 0, then Y is automatically forced to be 0 because no basic means no supplemental. And so both X and Y 0 means density will be 0. We are looking for where the density is positive. So that's why X needs to be positive. Y can be 0 because it's possible that no one buys the supplemental. So we want the probability that fewer than 5% buy supplemental, which means Y is less than 5%, given that X is equal to 10%, 10% buy basic. So Y is less than 5% given that X is equal to 10%. And our usual formula, Y probability Y is less than 0.05 and X is equal to 0.1 divided by probability X is equal to 0.1. And let's first examine the denominator. We want to see what the probability X equals 0.1 is. Now when X is 0.1, you substitute the 0.1 here, so you get 2 times 0.1 plus Y for the PDF. It's 2 times 0.1 plus Y, so that's 0.2 plus 2Y when you distribute. And X and Y, remember, Y is, on Y we have this restriction, bigger than or equal to 0 and less than or equal to X. But X is 0.1, so Y will be bigger than or equal to 0 and less than or equal to 0.1. Yeah. So 0 to 0.1, the integral of PDF, and that eventually gives us 0.03. Now examine the numerator. So once again, X is 0.1 even for the numerator. But now we have Y less than 0.05. And we also have the basic restriction that Y is between Y is greater than or equal to 0 and less than X, and X is 0.1. So Y greater than or equal to 0 and less than 0.1, and then we have Y greater than or equal to 0 and less than 0.05. So the overlap of the two is less than or equal to 0.05. Okay. In overlap, you just take the common region, and the common region is obtained by taking the smaller Y value, the smaller Y bound. Okay, so now we integrate this from 0 to 0.05, the same PDF, and we end up getting 0.0125, and now we have both the numerator and denominator. Numerator is 0.0125, denominator was 0.03, and we end up with 0.417, which is choice D.